All right, folks, it's Back in action here. In this video, we are going to go through the Pythagorean Theorem and the Converse Pythagorean Theorem. In the last semester, we talked about the triangle inequality theorem. So just a quick little note right down here. The triangle inequality theorem told us that the sum of any two sides must be more than the third side. Now, this allowed us to determine whether or not three numbers actually made a triangle, but it didn't allow us to determine what type of triangle we necessarily had. We could sometimes figure out if it was scaling, but we didn't know whether or not it was a right, obtuse, or acute triangle. The converse Pythagorean theorem is going to allow us to do that. So what we're going to do is we're going to look at that good old Pythagorean theorem that we already know, c squared equals a squared plus b squared. Of course, c is the longest of the three sides that you're given. That's really important, okay? If it's a right triangle, of course, this will be true. So what we'll notice is that we'll get a nice equal sign here. When we calculate our c squared, it'll actually match the sum of the squares of the other two sides. So we'll get a right triangle. Now, I'm going to say this several times. It's important that you check this triangle inequality theorem first, because A, B, and C have to be sides in a triangle. If it doesn't make a triangle, you can't even check these things. Now, the next thing that you can do is you can find, if it's not equal, you can look at that c squared, okay? Always find that c squared first, okay? We're going to find that c squared, and if that value is more than the sum of the squares of the other two, the a squared and b squared, the triangle will be obtuse. If that c squared turns out to be less, then the triangle will be an acute triangle. So what I've got over here are four little examples, and we're going to take a peek at those real quick. So the first thing we would do each time is we would check to make sure that it's a triangle. So we would find our largest. So we'd say 16 is the largest, and of course 6 plus 11 is more than 16. Now what we're going to do is we're going to square the 16, and that's going to give us 256. And then we're going to square the 6 and 11, so we'll have 36 plus 121, and that's going to give us 157. And we can see that the c squared is more than the 157, so this triangle would be obtuse. Again, we had to check that it was a triangle first. The next thing that we're going to do is we're going to look at our next one. We're going to find our largest value, our 16. We'll add the two other values together, our 5 and our 11, and that equals 16. Remember, equals isn't okay, so we can't say 5 plus 11 equals 16. That's not a triangle. So we would just stop. There's no additional analysis that we could do on that problem. The next thing we're going to do is we're going to take a peek at this one. Now, sometimes the radicals can be a little bit trickier to figure out which one is the largest. It's not necessarily given to you in order. 4 radical 5 is larger because, of course, square root of 5 is a little bit more than 2, and 4 times 2 is certainly going to be more than 8. So that's a good, quick, easy way to figure out that that one's going to be bigger. Now, 4 radical 5 squared is, of course, 16 times 5, and that gives us 80. Now, let's go ahead and add the 16 plus the 64, and 16 plus 64 is 80. So these two are the same, so this would actually make a nice right triangle for us. Our last one, we're going to go ahead and we're going to look at our 5, our 2 square root of 17, and our 7. And the 2 square root of 17 this time is going to be our largest value. Again, what we can do is we can say, okay, square root of 17 is a little bigger than square root of 16. Square root of 16 would be 4. So we've got 2 times something a little more than 4. That, of course, is going to be bigger than 7. So that's, again, good way to check whether or not something is more than another, a radical is more than another. So let's square that. That's going to give us 4 times 17 is going to give us a 68. Squaring the remaining 2 and adding them together is going to be 25 plus 49, and that's going to give us 74. So now what we're going to see is that our c squared is smaller than the other sum, so this triangle would be acute. We're going to work with these quite a bit, but it's important that you know those rules. Now, the next thing that we're going to have is a small little vocabulary word, this Pythagorean triple. A Pythagorean triple is a set of 3 numbers where the 3 numbers form a right triangle, but also they are whole numbers. So when we take a look up here, we can find our right triangle, but this would not be a Pythagorean triple because 4 radical 5 is actually a decimal. That's not a nice clean whole number. A good example of a standard Pythagorean triple, one that you should be familiar with, are the numbers 3, 4, and 5. Those make a nice right triangle, and they are all whole numbers, so they would be a triple. Now we're going to do 2 quick little examples here. We're not going to go through all of these. We're going to do 2 quick examples, finding a missing value and finding the area of a triangle. So we're going to go ahead, and if we were asked to find DC, we could put our X there. We've seen this example before. We've done this one before. We're going to say our hypotenuse squared. We know it's a right triangle, of course. And then we're going to say our 81 plus our 3 radical 5 squared. So x squared equals 81 plus, remember when you square the radical, you have to square both pieces. So you're going to have a 9 times a 5, and you're going to get your 45 here. That's going to give us an x squared is a square, or is 126. I jumped ahead. I'm going to say a square root there. So we had our x squared is 126, and then I'm taking the square root of each side. Simplifying that radical, remember you have to be able to do that without a button doing it for you on your calculator, and that'll give us 3 square root of 14. The last one that we're going to do is we're going to find the area of this triangle. The first thing that I want you to notice on this triangle is that it is not a right triangle. Okay, this is not a right triangle, which means we cannot just pick 2 sides and do 1/2 12 times 8, because this is not forming a right angle. Now, I've trained you to not use your eyes, but you could now use your Converse Pythagorean Theorem and quickly check to see that no, this is not a right triangle. So we can tell, however, that it is isosceles. So what we're going to do is we're going to draw in the height from that vertex angle, and remember that it's going to then bisect this side. If we do that, we can use our Pythagorean theorem to work with one of these little right triangles, and we can actually find the height of this triangle. So we're going to say 12 squared, and then we're going to have our height of our triangle squared plus our 4 squared. That's going to give us, for our height, we're going to get h is a square root of 128. Now, I did jump ahead. That meant that I took 144 minus my 16 and got me to my 128. That, of course, is then going to simplify, and it's going to give me an 8 radical 2. I'm skipping over the simplifying of the radicals because we've been doing these all year long. Now, when we go to calculate the area of this triangle, we want to do 1/2 base times height. Now, the base and the height of this triangle, we're going to find the base is going to be this entire side and our height that we just calculated. So we're going to have area is going to be 1/2. The base is that entire side of 8, and the height we just calculated of 8 radical 2. Remember, when we multiply these, all the numbers outside the radical get multiplied together. So 1/2 times 8 is 4. 4 times another 8 then is 32. So the area of our triangle is 32 radical 2 units squared. And that's all the examples that we're going to do on Pythagorean theorem here, and we will continue with the rest in class.